So now that you know a little bit more about the structure and functionality of a reentrant lock, let's talk about some of its key methods. And we've talked about a few of these before, but we'll go through them more systematically now. As you can see, there's a lot of methods in reentrant lock, many of which we don't really need to use as application developers most of the time. Things like get queue length, or has queued threads, or get wait queue length. There's a lot of things that are used primarily for diagnostics when you're implementing this thing and testing it that really aren't needed by many application programs. Here are the four key methods: lock, lock interruptibly, try lock, and unlock. And as you'll see, these methods are defined in the Java lock interface. So the lock interface is then implemented by the reentrant lock. And the implementations of all these methods simply forward to the underlying methods that are inherited from either the abstract queued synchronizer class or either the non-fair sync or fair sync subclasses that indirectly inherit from abstract queued synchronizer. So we'll see how these things all work. And you'll notice, like, when you do a lock, it calls lock on the sync. When you call lock interruptibly, it calls acquire interruptibly with a count of 1. When you call try lock, it calls non-fair try acquire with a count of 1. That's the one we just looked at in the previous slide. And when you call unlock, it calls release with a count of 1. So you get a feeling here that unlike the semaphores where you can acquire chunks of things, like multiple permits at a time, the reentrant lock is only doing one thing at a time, either acquiring or releasing one count element. Lock is probably the most, it's the starting point for this whole thing. Its purpose is to acquire the lock if it's available. If the lock is not available, then what happens depends on the fairness policy that is enabled when you created the reentrant lock and passed the parameter to its constructor, or just use the default constructor. So if you have a non-fair implementation, either the default or false to the constructor, that will be optimized in hardware. And it'll actually use a little kind of a spin lock, check to see whether or not it can get the lock, and if not, it'll basically sort of spin. So that's how things work for the non-fair policy. It tries to get the lock. Fair implementations will just park themselves on a wait queue and wait in FIFO order for their turn to get the lock. So they get stuck on a queue. And you can see when we get a little further along and you guys get a chance probably to implement a semaphore that has fair semantics, you will see that they're much more complicated to implement and much less efficient. And you'll understand why people are so interested in using the non-fair versions when they can't. The lock method is not interruptible. That's very much like the synchronized keyword, which doesn't allow interrupts. Lock interruptibly, in contrast, is interruptible. That's the only real difference. Otherwise, it behaves the same. So you can, if you interrupt a thread that has got an interruptible locked, then that will cause the interrupted exception to be thrown, and you can basically catch that and do something in response. So it's a way to shut things down more gracefully and more quickly. Try lock with no parameters returns true if it's able to acquire the lock immediately, and otherwise returns false. And one of the interesting quirks about try lock with no parameters, which is called the untimed try lock, is that it does not honor the fairness setting. So you could have created this reentrant lock with true for the fairness, but if you call try lock, it'll just barge ahead and try to get, whenever you call try lock, it'll just try to get the lock. And even if there's other threads that are waiting in line. And we'll see how to fix that in a minute. It's a very strange semantic as far as I'm concerned. And then the final method that's really important is unlock, and it attempts to release the lock. And I say it attempts to release the lock for a reason, because if you don't own the lock and you attempt to release the lock, if you're not using fully bracketed locking semantics, then it'll throw the illegal monitor state exception. So in other words, the way to think about this in terms of the terminology we came up with a couple classes ago is that, when we were talking about semaphores, is that reentrant lock is expected to be used in a fully bracketed manner. You cannot use a reentrant lock in a non-fully bracketed manner because it'll get the illegal monitor state exception. If the hold count is greater than 0, the lock is actually not released. It's just its hold count is decremented by 1. So lock and unlock will be used in a recursive reentrant type way. There are a bunch of other methods. I'm not going to go through all of them. I'll just go through a few of the ones that are most useful. And these methods go well beyond what's available in Java's synchronized statements and methods. So try-lock is a timed version of the untimed try-lock we talked about before. And it's got two main differences from the untimed try-lock. Number one, you can give it a timeout. So you can say, try to get the lock, but only wait up to this amount of time. So that's pretty straightforward. And the other thing try-lock does is it actually does honor the fairness setting. So if you want to do a non-blocking or not very long blocking timed lock that honors the fairness setting, call try-lock with a timeout of 0. And that will honor the fairness setting. So it will not barge ahead of other threads. It'll basically just fail. There's a method that returns whether or not the lock is a fair sync or non-fair sync. There's a method that returns whether the lock is locked. That is actually not a very useful method, and that's because of the non-determinism of concurrency. By the time you get back an answer whether the lock is locked or not, it may already be locked. If it says unlocked, by the time you get the fact that it's unlocked, it may be locked. So it's really not a very useful method, but it's there. A method that is very useful, which we will talk about next class, in which you'll get a chance to play with, is Java condition object, which is used with Java condition object. And it's called new condition. And it's a factory method that returns a condition object instance that's intended to be used with this particular lock instance. And we'll talk more about that when we talk about condition objects. So that's the end of the key methods in this class.